projectile motion problems. I'm going to try to make this video as short and sweet as possible, so forgive me if I'm not explaining everything to the fullest. I will definitely do that when we review this section for the test. But what you need to know right now to help you do your practice is to understand that projectile motion problem. So when something's being thrown in the air, for example, are parabolas. They're quadratic functions. So like if I am kicking a ball, all right, say I start kicking it here, it goes upward in the air, it reaches a maximum height, and then it starts to fall down until it eventually hits the ground and stops. So it could look like this. You'll notice that all of these examples have negative parabolas, right? Because we're throwing something, it's reaching a maximum height and then it's falling down. So in these problems, I'll tell you, when it's asking for things like maximum height, it's asking for this. Or when it's asking for how long until the ball reaches the ground, this is what you'll do. And that'll kind of help you. And I'm hoping that you're like seeing on these diagrams, like why that is. So first we have a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation is h equals negative 16t squared plus 90t. So that will give the height of the ball after t seconds. All right, so basically the t is our x value, right? The t is our input. So x equals t, which represents time. And the y value is replaced by h, which represents height. Now, first it's asking, find the maximum height of the ball. So I want to know the h value or the y value when the ball has reached its maximum height. So think about where you might have heard that before when we talk about maximum, like the maximum point on a graph. Well, the maximum point of a parabola is called the vertex, right? It could be a maximum or a minimum. In these ones, it's going to be a maximum because the ball will eventually reach the top and then fall down. So I want to know my y value of the vertex. And you can do this a number of ways. What I find works good for these is using that axis of symmetry equation. So here it is, x equals negative b over 2 times a. Remember that standard form of quadratic functions is this. So if I plug this in to this equation, all right, my b value is 90, right? It's in the b position. And then my a value is negative 16. By finding the x value, I can then find the y value. So I plug this into my calculator and I get an answer that is about 2.81. All right, that's what these squiggly lines mean, that I rounded this number and it's about 2.81. So with this x value, I'm going to plug it into my given equation, and that will give me the y value. All right, so I have y equals, or h equals, because remember, this is our little key here. All right, so we have h equals negative 16 times t, which we said is 2.81 squared, plus 90 times 2.81. I would enter this part into my Desmos calculator, exactly how it looks. And then I would get an h value That is about 126.56, and the unit that we're working with is feet. All right, so when you see problems like this, what is the maximum height of the ball? Well, what I'm asking you is, what is the y value of your vertex? So if you want to make a note like that for like these other ones, what's the maximum height of the apple? We're looking for the y value of the vertex. All right, maximum height of the container. We're looking for the y value of the vertex. All right, how do I find the vertex again? I can use my axis of symmetry equation, figure out what x is, and then plug in x into the equation and solve for y. All right, so now I'm going to go back up to that first example we were doing because there's another part to it. Part B says, how many seconds will it take for the ball to reach the ground? Well, whenever you see reach the ground, well, what could it possibly be talking about? Like, what part of the parabola are we looking at? So, like, if we use this example, all right, so it gets thrown here and then reaches a maximum height, starts falling, and then it stops right here. Same with these over here, when it reaches the ground, would be at the end of its journey. And that would be when this y value or this h value, when the height is equal to 0. So we're gonna basically associate anytime it talks about reaching the ground, well, we're saying that the y value, or in this case, the h value, because y is height represents the y value. We're looking for when this is going to be equal to 0. All right, so all I really have to do for these types of problems is plug in 0 for the h into the equation that we're given. So h, which is now 0, equals negative 16t squared plus 90t. All right, we can solve this a number of ways. If you want to see how it's solved by factoring, then look at the notes in Schoology that are posted. But to save time on this video, to kind of make it short, I'm going to plug this into Desmos and basically solve it by graphing. All right, just know that when you plug stuff into Desmos, you're going to want to change that variable, that t, to an x. All right, it doesn't read like the t squared. See, like it just doesn't understand. But if I put an x squared, it now knows what I'm talking about. So negative 16x squared plus 90x. And we're going to look for where it crosses the x-axis. And we can only have one answer. So how many seconds will it take for the ball to reach the ground? Well, if I'm looking at the value that's on the left, so 0, 0, so when no time has passed and it has not been kicked, would be this left value. And this other value would be when about 5 to 6 seconds have passed and the height is now 0. So when deciding which of these makes more sense, I would go with the one on the right because the ball is traveling like this essentially. It's going from 0, 0 from the start to 5.6250. So that x value, that t value is going to be 5.625 seconds. right? So that will go here, 5.625 seconds. Right, so then when you scroll down to these other problems on here, how many seconds will it take the apple to reach the ground? All right, we're talking about what's the t value when h is 0. So we're just plugging in 0 into whatever equation they give us. And they have different equations for each problem. Use whatever equation that they give you. All right, let's see if there's any unique problems on the back, because I believe number 3 is the same. All right, how many seconds will it take for the container to reach the ground? So h equaling 0 again. Looking at the backside now. A penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by this equation, how long would it take for the penny to strike a 6-foot tall person? All right, so we're not just asking for when this penny would hit the ground, we're looking for when it'll hit a 6-foot tall person. So think in your head where that would go. So what are we solving for? How long would it take? So it sounds like we're solving for time. So we're solving for t. And we're solving for t when h equals 6. All right, because if we're waiting for it to hit a 6-foot tall person, well, we want to know essentially. So here's my building, pennies being thrown off of here. We want to know when it reaches here. All right, so not quite the ground underneath. We want to know when it reaches a 6-foot tall person. So that means I'm going to replace my h with a 6. We get negative 16t squared plus 1250. We want to make this look like our standard form of a quadratic function so that we can solve it, which means that we set this equal to 0. So I'm going to do that by subtracting 6 from each side. Cancels out on the left side. I now have wait, let me backtrack a little bit. Okay, sorry. I now have to subtract 6 from each side, so negative 16t squared plus 1,244. All right, I'm going to enter this in and see what I get. So negative 16x squared plus 1,244. All right, so notice we're looking for when it crosses the x-axis. So we crosses the x-axis here and here. Now, for which one is the correct response and which one is not? Well, are we looking for when the time is positive or when it's negative? All right, so are we looking for before it was thrown, would be like the negative value, to after it was thrown, which would be the positive value? Right? The correct answer would be the positive value. So I would go back here and I would say that the t value is about, so we'll use the squiggly lines, 8.82 seconds. All right, so that just kind of do the best you can to reason with what it's asking for. Is it asking for, this part of the graph or this part of the graph? Then set up your problem and then solve like you normally would, like we have been in class. You can use Desmos, you can use a quadratic formula, you can do it by factoring. All right, what I would really like for you guys to do is to try out a few of these problems that are on your notes sheet and see if you get the right answer. So like over here on the first page, those are the ones that look most like your practice. I would want you to try out maybe 2, maybe 3, and see if you get the right answer. The notes are posted in Schoology so that you can check your answers. And then you should be able to do the practice no problem because they're mostly like 1, 2, or 3. But let's look at these other ones, see if there's anything different going on. So for number 5, I'm just going to kind of highlight the key points here and hopefully that'll help you out with what to do. For number 5, it's asking how long will it take for the fireworks to reach the ground? So the reach the ground is the key part here. All right, that would be when h equals 0. So solving for t when h equals 0 would give you the best bet here for finding that answer. Number 6 is looking for the maximum height. So you need to find your vertex. And since t is my x value and h is my y value, I'm looking for the y value of my vertex. For number 7, we have Eva is jumping on a trampoline. Her height at the t time can be modeled by this equation. Would Eva reach a height of 14 feet? So this one is a fancy way of asking you, would the maximum, so would the vertex, so you need to find the vertex, and given that the y is the one that represents the height, is this y value greater or equal to 14? So is y or is h greater or equal to 14? All right, if it is, then that means, yeah, she'll reach that height. If it's not, then no, she won't reach that height. So you have to figure out what the vertex is, figure out, look at that y value. If it's greater or equal to 14, then yes, she would reach that height. And then lastly, this one's a bit more of a challenging one. And I'll let you kind of read through it. But essentially what you need to figure out is, how long does it take for each one to reach the ground? So how long for each to reach the ground? And then we know that reach the ground means that h would be 0. And then compare the two t values. All right, I hate that I can't be there today to share this with you, to like really explain to you why that makes sense. We will have time to talk about it before the test, and it'll be even better because I'll know exactly what type of problem you'll see on the test by then. But if I could give you some direction, it would be to really understand these first 3 problems. All right, so maximum height, we're looking for the vertex, right? Because the vertex is where your maximum height would be. How long would it take to reach the ground? We're looking for that x value or that t value when the quadratic is set equal to 0. Right? Nothing like these calculations that we're doing, you've all learned. It's just applying it to the real world situation. Basically, can I figure out what this problem is asking for? So try your best on the practice. We will talk about it more on Tuesday. And if you have any questions, feel free to email me and have a good day. Make sure you look at the notes in Schoology.